For question 1c, so I would try to graph this. I'd plug those into my calculator, and I'd look at the graph of that. And you get kind of an interesting graph. In fact, it kind of looks like that hyperbola situation that you had on the problem set. And it's kind of interesting that our window just goes between negative pi over 2 and pi over 2. I wonder if we went between, negative 2 pi to positive 2 pi, if this would look any different. Well, it looks like we get both branches of the hyperbola. And if you remember from your problem set with the hyperbola, you have a set of asymptotes here. And if I were going to look at this, I would say the x-intercept looked like it's 1 and negative 1. So I would guess that in rectangular coordinates, this would be something like x squared over 1 minus y squared over 1 is equal to 1, if you remember what I had written about a hyperbola. So let's see if we can reproduce that. So what I know about secant and tangent, well, in fact, I don't really remember the trig identity for secant and tangent, but I know sine squared plus cosine squared is equal to 1. And I know that if I want to develop tangent, I'm going to divide everything by cosine squared. Cosine squared, cosine squared. So I do remember that trig identity that is, in fact, tan squared t plus 1 is secant squared. And I'm going to substitute this right into what we have. So tan squared t, well, that's nothing more than y squared. So that gives me y squared plus 1 equals secant squared. And if I square that, that's going to give x squared. And that leaves me with y squared minus x squared is equal to negative 1, or better yet, x squared minus y squared is equal to 1, which is exactly what we predicted. Then the problem is, why do we only get one branch of this? Why do we just get the left-hand branch of this hyperbola? And as long as we know that t goes between negative pi over 2 and pi over 2, well, as far as the y value is concerned, I know that tangent's behavior between negative pi over 2 and pi over 2 is increasing. So I know that the y value is only going to be increasing. So I know that the direction of motion has to be in the motion of direction of increasing y. As far as x is concerned, negative secant, if you remember the graph of secant, that is the reciprocal of cosine. So secant would just be kind of like almost a parabola opening up, but negative secant is going to open down. So as t increases, my x value goes from very negative to negative 1, and then back down to very negative. So my restrictions on, because of this t value, is that my x value here, so I'm looking at x as a function of t, my x value has as its range negative 1 to negative infinity. So I'm not going to see the right-hand side of this because of the restriction on x.